Reporting on Game Day Live from Soldier Field, it's Mr. Richards back for your Math 3 2.3a review, kicking it off with number 1, interpret the graphed polynomial. I brought in some tips for us, okay? Our end behavior, the coefficient of the lead term determines its end behavior. When it's a positive coefficient, it equals up, and when it's a negative coefficient, it equals down. And yes, I did color in our start to end, even though we read it left to right, start to end, because on our next one, it will just be black and white. Let's go ahead and take a look at some of our answer choices here. All right, for A, it says odd degree negative coefficient. We want to start with the coefficients, because when it's a positive coefficient, we will end up. And when it's a negative coefficient, we will end down. Is this ending down? No, it's ending up. Anything with a negative coefficient within the answer choice, we will get rid of. Positive coefficient, negative coefficient. Let's go ahead and get rid of it. And I'll actually highlight why we got rid of it. And then our positive coefficient here. So we still have two answers in play. All right, now that we know that our positive coefficient, because it's going up, now we need to look at where it starts, and the degree of the polynomial determines its start. All right, when it's an even degree, 2, 4, 6, 8, 10, it starts in the same direction as its end behavior. Oh, okay, starts in the same. Let's just read through. An odd degree equals starts in the opposite direction as its end behavior. 1, 3, 5, 7, 9 would all be pointing downwards, so we need an even degree to go with it. Well, let's take a look. We have the positive coefficient that we knew, but it has an odd degree, and an odd degree starts in the opposite direction. Well, it's starting upwards and it ends upwards. Let's go ahead and get rid of answer choice C, which makes B our double win. Yes, we have the positive coefficient in red, and yes, we do have an even degree in blue. Go ahead and circle B for your answer choice. For number 2, choose the function that would best represent the graphed function. I left the notes in, no colors. We should know where it starts and where it ends. So let's go ahead and take a look, all right? It's looking for us to choose a function. Well, I always like to start with 1. Where does it end? All right, well, it ends, yes, good job, it ends upward, all right? And if it ends up, that means we need a positive coefficient of our lead term. All right, so I'm going to look at our coefficients here of our lead term. All right, well, we have a negative 7 here. It needs to be positive, so we go ahead and get rid of it. So now any answer choice with a negative coefficient, we can get rid of. C is negative as well. Let's get rid of that. All right, now we can jump right into, well, where does it start? All right, well, we know we have a positive 4 and a positive 6, but now we need to look at the degrees. All right, so I'm going to highlight our 5, and I'm going to highlight our 4. Remember, an even degree starts in the same direction as its end behavior. So if an even degree, like it is here, means they would both point upward, same direction. And we know that it's an opposite direction. So why don't we go ahead and circle B is our answer, because it does have exactly what we're looking for. It has that positive 4 determining our end behavior pointing up, and it has an odd degree, meaning it's going to be an opposite. So if it ends up, it needs to start down. B is your best answer choice. Moving forward to number 3, yes, I went and added the synthetic division in for you, but also at the end of this, I'll give you a tip on how you can solve as well. All right, so it just wants us to find the remainder when negative 2x cubed plus 8x squared minus 3x plus 15 is divided by x minus 3. Yes, I spaced it out on purpose. Yours will be very close together, but just to demonstrate it as I show you for your learning and understanding. All right, so step 1, I wrote them out. Go ahead and look at our divisor. All right, we need to set x minus 3 equal to 0. And when we do so, we solve for x. Well, we need to get x by itself, so we add 3 to both sides. Essentially, x equals 3. And that right there is your divisor, that positive 3. And if you notice, we just took a negative 3 and made it positive, and we'll do that throughout. All right, for number 2, it says coefficients and constant setup. There's a reason why I did this, always a reason to my madness. This negative 2 is a coefficient of x cubed. So I'm going to write down our negative 2. All right, our plus 8 is our coefficient of x squared. So I'm just going to write an 8 down, not the plus. All right, our negative 3 is the coefficient of x. I'm going to drop a minus 3 down, or negative 3. All right, and then our plus 15, well, that's just our constant right there. All right, so we're just going to drop our 15 down. First two steps are out of the way. Step 3, drop first coefficient. All right, so I'm going to do that in green. I'm going to take our first coefficient, which was this negative 2 here, and I'm going to drop it straight down. I actually like how Notability gives you like the arrow, auto. Love it, negative 2. All right, from here, what we're going to do is we're going to distribute our divisor, which is 3. We're going to combine like terms and continue. All right, so 3 times our negative 2 equals negative 6. I'm actually going to write that then as the minus 6. And our combining like terms is simply 8 minus 6, which equals 2. All right, then it said to continue. So I'm going to take our 3. We're going to multiply it times 2. Yes, that equals 6. I will put a plus 6 there. You don't have to, but negative 3 plus 6 gives you a positive 3. And I will do that one more time for this one. 3 times 3 is 9. So I can write it as plus 9, or you can just write it as 9. Enter that in your calculator. 15 plus 9 is 24. Go ahead and circle your answer. Now, what you could have done for this and what you can actually do for both 3 and 4, just a little trick. We found our divisor, x equals 3, correct? So what you can do is you can plug it into the function just like this. So I would do my negative 2, and then every time I saw an x, I'm just going to go ahead and put it in parentheses with the 3, and I'll cube it because this one wanted me to cube it. Then I will write plus 8 because that's what it wants me to do. I see an x, I put it in parentheses, I square it, and then again our original function says minus 3 with an x, and again, we're simply just plugging in for our x, put that in parentheses, rewrite your plus 15, and if you put that in your calculator, you will still get your 24. And you can do that for number 4 as well, and the reason being, all right, determine the result of using synthetic division when dividing, okay? So of using, well, let's take a look. We have a remainder of 23, 54, negative 91, and 57. Whoa, so they're all different remainders, which means you can simply plug it in. What is x equal to, taking what we know from what we just learned? Yes, it's x minus 3, so x equals 3. Great job. All right, I will set up for the synthetic because I do want to show you something here. There's a reason being. We have x cubed, we have plus 5x squared, and it jumps to minus 15. We don't have an x by itself or an imaginary x to the first, and that we'll have to add in. So let's start with the coefficient of x cubed, which is, what's that imaginary number in front of x cubed? Yes, it is a 1. We'll put it up top. All right, so our next coefficient is plus 5, so we can just write it as 5. Now, because we don't have an x to the first, I'm just going to draw like a little arrow here. And it wouldn't be x to the first, it would just be written as x. All right, and it's not there. So if it's not there and we don't see it, we still have to add it, except we're just going to put in a 0 to replace it. Then drop your minus 15. From here, we will do the exact same thing. We will drop our first coefficient, which is the 1, and then we will simply distribute our divisor, which is 3. 3 times 1 equals 3, or a positive 3, plus 3. 5 plus 3 is, yes, 8, and then we'll continue throughout. 3 times 8 is, wonderful, 24. So you can write it as plus 24. Bring down your 24. 3 times 24 equals 72. Negative 15 plus 72 leaves us 57. Now, if you were to write this, well, right away we know we can just circle C because it's the only one that clearly has the 57 as a remainder. But if you were to write this, it would look like x squared plus 8x plus 24 plus 57 over our x minus 3. Moving forward to number 5, and you'll see a little bit more of that with number 7. Find the value of p of x equals 2x cubed minus 4x squared plus 5x minus 12 when x equals 2. Plug in what x is equal to. In this case, it's 2 for x. All right, so just like I taught you above, you can simply just plug it in. All right, now for this one, we're just going to plug it in because that's what it's asking us to do. So for the synthetic for number 4, again, you didn't have to if you didn't want to. So we're going to start with our 2. All right, our x is 2, and it wants us to cube it. All right, we're just going to go through term by term. All right, then it says to do minus 4, so I'm just going to do minus 4. All right, and then there's an x there. What do I do with my x? Yes, I just wrap it in parentheses, and I square it just like it has here. Then we just do plus 5, so I'm going to do plus 5. Oh, another x. Let's put that in parentheses, followed by minus 12. And then we're just going to write equals, and we will plug this into our calculator. 2, open a parenthesis. 2, close parenthesis. I need you to up key arrow right above division. Type in the 3. All right, but we need to hit the right key arrow over to get us back to ground level. Now do your minus 4, open a parenthesis, 2, close parenthesis. You can either hit x squared or you can do the up key arrow 2 again. I will choose to hit x squared because that keeps me at ground level. It only works for the square there. Then we will enter in plus 5. And again, with our parentheses, we'll put in a 2, close it, minus 12 equals negative 2. And negative 2, let me clear this and just get rid of it, is your answer for number 5. All right, for number 6, find the polynomial function with zeros 2, negative 3, and 5. So this is going to take a little bit of time. I'm just going to go ahead and highlight our 2. I'm going to highlight our negative 3, and I'm going to highlight our 5. All right, step 1, write 3 roots as polynomials. All right, well, we know that if x equals 2, well, when we first saw it then, if we're going to write that as a polynomial, it's just x minus 2, again, taking the flip or the inverse. All right, so we have x minus 3, which becomes wonderful, x plus 3, and then we have x, which would be a positive 5, so we'd write it as x minus 5. All right, I'm just going to jump to step 2 and read it aloud. There is a method to my madness. Multiply 2 polynomials. I do blue and green. There's a reason for this. It's because of number 7. So I'm going to multiply blue and green. Red, I'm just going to let it chill and hang out. All right, x times x gives us, great job, x squared. X times negative 5 gives us, wonderful, minus 5x. 3 times x is 3x, so plus 3x. 3 times negative 5 is negative 15. All right, but then it says within that, oh, when I multiply, then I need to combine like terms. So we've done the multiplication. Now we just need to combine like terms. Well, let's take a look. Our x squared, we can't combine it with anything. I'm just going to rewrite it. I'm actually going to bring it down just a hair. Minus 5x. Ooh, there's another term with just an x, and it's plus 3x. Well, negative 5 plus 3 leaves us minus 2x, and then minus 15. Well, we can't combine it with anything, so we're just going to do minus 15. All right, I'm actually going to put this in parentheses. All right, because now it says for number 3, multiply a new polynomial, which is x squared minus 2x minus 15, with remaining polynomial. For me, it's red. For you, if you did red and blue, it would be green. If you did red and green, it would be blue. But again, there's a method to my madness, so I will do orange and red. Our red one, which was x minus 2, I'm just going to rewrite it down here. All right. Part of the madness is that, well, now I'm only distributing 2 terms to 3 instead of 3 into 2. All right, so let's go ahead and distribute now. We're going to do the exact same thing. We're just going to distribute and combine. All right, x times x squared gives us, wonderful job, x cubed. Sorry, it's supposed to look like a 3, not a 5 or a 3. X minus 2x gives you minus 2x squared. Remember that we have to add those just like we did before. X times negative 15 is minus 15x. And then we will work below the c because we just did over the rainbow. Negative 2 and x squared. Let's multiply those. We get negative 2x squared. Then we'll do negative 2 times negative 2x. Negative 2 times negative 2 gives us a positive 4. Don't forget the x. Negative 2 times negative 15 gives us a positive 30. We combine like terms here, and then we're done. All right, our x cubed, can we combine it with anything? Does anything else have an x to the third power? No. Go ahead and write your answer. I'm just going to scratch it off. We used it. All right, now I'm going to circle my negative 2x squared. Reason being, I noticed right away, I'm like, oh my goodness, there's another negative 2x squared. Negative 2 minus 2 is negative 4. Don't forget your x squared. Yes, it stays squared because we're simply adding and we're not multiplying. All right, negative 15x. Can I combine that with anything? Sure can. Positive 4x, negative 15 plus 4 equals negative 11. Don't forget your x. Bring down your plus 30. That doesn't get combined with anything. And now you have your answer. And moving forward to number 7, given the solution x equals 4 to the equation x cubed minus 6x squared plus 10x minus 8 equals 0, find the conjugate roots. Actually, let's find the complex root and then the conjugate of the complex. Wonderful. So we're given the solution of x equals 4. That's big for us because we already know what x is equal to. And what do we know for step 1 in finding our divisor? We need to find what x is equal to, and they're already giving it to us. So x equals 4, beautiful. Then we will move on to step 2, coefficients and constant setup. All right, the coefficient of x cubed is simply that imaginary 1. So we're just going to do a 1. From here, I'll highlight through. Coefficient of x squared is, wonderful job, negative 6. Leave a little bit of space for yourself. All right, the coefficient of 10x is simply, yes, great job, just 10. And then our constant, I know, I'll highlight it too. It's negative 8. Great job. You guys are kicking some serious butt right now. All right, then we will move to step 3. Drop our first coefficient. Let's see if it makes that nice perfect arrow. No, it didn't, but we'll just drop our 1. All right, then we will distribute our divisor, combine like terms, and continue through. All right, so 4 times 1, that's going to give us 4. Negative 6 plus that 4 leaves us a negative 2. 4 times negative 2, well, that equals negative 8. 10 minus 8 is 2. Then we will do 4 times 2, which is 8. And negative 8 plus 8 doesn't leave us anything, so that equals 0. Beautiful. All right, so we've worked through that. Now we need to rewrite as quadratic, subtracting an x from first 3 terms. All right, and label A, B, and C values, modeled in color. I'm actually going to model in black and white. I just forgot to change it because I want to use those colors a little bit later in the game. All right, so we are going to subtract an x from the first 3 terms. All right, so our 1, these are our new terms here. All right, we have a 1, but it was an x cubed. If we take away an x, it's now going to be, yes, great job, x squared. Our negative 2 will bring down, which was once an x squared, now becomes simply an x. Then we have a plus 2, which will come down, which once had an x, it now does not, because x minus x doesn't leave us anything. And which was minus 8, well, we know now is equal to 0, so we can just put equals 0. Beautiful. All right, but it does want us to label our A, B, and C, and as we remember from last year, all right, the coefficient of x squared will be your A, the coefficient of x is your B, and your constant will be your C. Then we need to plug into the quadratic formula, and we're just simply going to do that. So x equals, it wants the negative sign. Wonderful. Then it wants us to put in our b value. Well, our b value is -2. So make sure to put it in parentheses just like it is written. I do that on purpose because our calculator will get confused at times. So let's just please do so as we need to. All right. Equals, and we'll bring down our plus minus. All right, I'll open up our radical here. And then our b value is -2. We'll square it. All right, -4, writing it as so. Our a value is, great job, it's just simply a 1, times your c value, which is 2. All right, and then we will set that over 2 times a. So 2 times 1. All right, from here, we will sequence the quadratic formula, and I just want to do the arithmetic with you. All right, so our x equals, I'm just going to bring down. All right, now in our calculator, when we do negative times -2, we do get a +2. All right, so x equals 2 plus minus, we will open up a square root. All right, and then in our calculator, I'm going to do what I highlight in blue. All right, now I didn't highlight our radical here, or our root, so that means we're going to keep it, and that's why I wrote it here. And then we're just going to enter this into our calculator, like so. We're going to open a parenthesis, -2, close it, hit x squared, do -4, open, put in a 1, close, open, put in a 2, close, hit enter, we get -4. All right, so I'm going to write -4 underneath our radical here. And then in green, we do 2 times 1, so we need to set that over 2. All right, now from here, just going to open up our x equals again. I'm actually going to draw or add my red 2 and put in my plus minus. Because step 4 says take square root of negative or rewrite with factors of negative with greatest perfect square. Well, we know that 4 is a perfect square. I'm actually going to highlight that in brown. All right, and we're going to take the square root of it there, all right, which is simply 2i. We're going to put that over our green 2. We have now worked through the first 4 steps. Now, step 5 says to divide the numerator, or in this case, we have 2 plus minus 2i, numerator terms by denominator, if possible, and right answer. Well, 2 is definitely divisible by 2, so we are going to do that in pink. All right, so x equals 2 divided by 2, which is 1. Let me actually put that in black for the x equals. 2 divided by 2 is 1. All right, we're just going to write it as an answer. You could leave it as plus minus, but let's just go ahead and do it. Is 1 plus 2 divided by 2 is 1. Don't forget the I. And then we also have x equals, and then we will do the exact same. 2 divided by 2 is 1, except instead of plus, we'll just write it with a minus. 2 divided by 2 again is 1, and don't forget the I with it. All right, so if you're sequencing through long term for number 7, yes, it's going to be the toughest for you to get through, but trust me, you can do that no problem. I'm actually going to try to do my best right there if you want to pause it, just so you can see how the sequence went through. And then we will move to number 8. Let me zoom back in here. Determine the minimum degree of a polynomial that has zeros of 6, -4, 3, and -3 plus 2i. Ooh, what do we know about that I right there? Yes, it's imaginary, it's complex, and complex roots have a conjugate root. And the conjugate root of -3 plus 2i is -3 minus 2i. So instead of plus 2i, we have a minus 2i. Now how many roots do we have? Well, we have 1 here, we have 2 here, we have 3, we have 4, and we have 5. All right, that's going to give us our degree, which is simply 5. And yes, I kind of messed up my answer key, but I went through this like 3 times trying to create problems and get them to match and have to restart all of the colors and everything that's already implemented. I could not do it again. It would take way too long over again. All right, number 9, list the possible rational roots when given the equation 6x cubed plus 7x squared minus 9x plus 7 equals 0. We're simply going to use plus minus p over q. But first we need to identify our p and our q. All right, now our p is going to be the constant term, the number that stands alone. And I'm going to highlight that for us. That's going to be our 7. So your p is 7. And your q, I'll highlight in blue, is going to be the coefficient of your lead term here, which is 6, because it's cubed, squared, and 1. Well, that's the leading term, and 6 is the coefficient of that lead term. Then it's going to ask us to write the factors. Well, the factors of 7 are simple. It's a prime number. It's just simply 1 and 7. But for 6, we could do 1 and 6. We can also do 2 times 3. So we're just going to write them as 1, 2, 3, and 6. The first one I'm going to do is I'm going to take my 7. All right, and we're going to do it just like this. And we're going to set it over 1. And we know that 7 over 1 equals, well, we're going to use our plus minus 7. Do I have any answers with a 7 in it? All right, A has a 7 in it. B down here, I don't see a 7. I'm going to get rid of it. C over here does not have a 7. I'll get rid of it. And neither does D. So A is ultimately your answer. Now, if it did want you to get more in-depth and thorough, all right, your next one would be 7 over 2. So plus minus 7 over 2. Plus minus 7 over 3. Plus minus 7 over 6. Then you would do the same with the 1s. Well, 1 over 1 would give you your positive 1. 1 over 2. 1 over 3. And 1 over 6, just in case you did have 2 and you needed to go back and check the answers. All right, for number 10, well, same thing. Which is a possible root of the polynomial equation 9x cubed plus 4x squared minus 5x plus 7 equals 0. Let's identify our constant as our p term, which is plus 7. So p equals 7. All right. Our factors of 7, again, are just simply 1 and 7. Then let's go ahead and identify our q term. And our q term is that leading coefficient there, which is 9. So q equals 9. And then for our q, we'll use 1, 3, and 9. All right, we don't want to use 3 twice due to 3 times 3, so we'll just use 3 once. And then from here, well, let's take a look at our answer choices. 9 over 7. Well, I can't do 9 over 7 because it's red over blue. So 9 over 7 is actually blue over red. So our first answer choice is definitely not correct. All right, let's take a look at B, which is giving us 9. Well, again, 9 over 1 is equal to 9, but that would be blue over red, and we need to do red over blue, so get rid of B. Answer choice C is 7 over 9. Okay, well, our P, we can take a 7, and we can definitely set it over a blue 9. So C is 100%. Our answer in 4 is just nowhere located, so get rid of it. All right, so for number 11, a polynomial with rational coefficients has the roots 3 and 3 plus 2i. Oh my goodness, what do we have here? We have a complex root. We need to write the conjugate of it. All right, so we have 3 plus 2i, which means we also have 3. God, that's a terrible looking 3. 3 minus 2i. Oh, and look at what A says. It says determine the additional root. Oh, okay, well, our additional root is simply 3 minus 2i. Then it wants us to find the polynomial, find the end behavior, to what degree is it, how many turning points. Oh my goodness. Guess what? It's not that bad. Our 3 will highlight in red. Our blue, I'll use right here for the 3 plus 2i. And then in green will be our third that we need to set up. Yes, I know. It's going to be a little bit of a process, but it's not too bad. All right. Now, we know our positive 3, if we bring that back into, would be x minus 3. Now, don't get confused here. All right. We're simply just going to take the opposite of our 3, which is negative 3, and the opposite of our plus 2i, which is negative 2i. So when we write it in blue here, all right, when we're writing it backwards, we're just going to write it as x minus 3 minus 2i. All right, close it. Then in green, I will open one, and we will write it as x, and again, it will be minus 3, except this time it will be plus 2i. From here, we've now done that. We wrote the additional root. We write 3 roots as polynomials. We've done that. I like to, again, okay, red, blue, and green, multiply complex root in blue with its conjugate in green. And this is why I did blue and green to start with last time, because I'm going to do it again. All right, x times x, what does it give us? Great job, x squared. X times negative 3x, wonderful, minus 3x. X times 2i, oh my goodness, plus 2xi, not ai, xi. All right, then we'll do negative 3 here times x, gives us negative 3x. Then we'll do negative 3 times negative 3, which gives us a plus 9. And then we'll do negative 3 times 2i, giving us minus 6i. All right, then we will go under the c. Negative 2i times x will be minus 2xi. Negative 2i times negative 3 will be plus 6i. And negative 2i times 2i will give us negative 4i squared. Oh my goodness, yes, my writing became a little bit small there because now we have to combine like terms. What? Yes, it's okay. We will work through it. All right, I'm going to circle an x squared. All right. Ooh, I don't need to circle it because is there anything else that's representing x squared? No, there's not. I'm going to set it and forget it. Easy bake oven, right? Let me actually just drop it right about there. Then I'm going to look at minus 3x. Weird. My notability is just on a slight delay. Anything else with just an x? Well, we have negative 3x. Again, anything else with just an x? Doesn't look like it. So negative 3 minus 3 gives us negative 6x. I'm going to box my plus 2xi. Anything else with a 2xi or an xi, shall I say? Oh, we have negative 2xi. Well, positive 2xi minus 2xi, guess what? It doesn't leave us any xi. Good. Get rid of it. All right. Then I'm going to look over here, and I'm like, okay, I have a 9. Can I combine our 9 with anything? All right. Our 4i squared, or negative 4i squared here. I'm going to zoom in tight. All right. What is I squared equal to? Does anyone remember? Yes. Good job. Negative 1. All right. So we have basically this last term is negative 4 times negative 1, which equals 4. And guess what? We now have a constant, 9 and 4. So I'm going to go ahead and write plus 13. Then I'm going to double underline. Just want to make sure that we use this. Negative 6i plus 6i. Well, again, those will cancel each other out because if you owed me 6i and paid me back 6i, you don't owe me anything. All right, what we have left here is x squared minus 6x plus 13. For some odd reason, I hope that looks right. I'll have to maybe even check my work at the end here. Yes, I forgot to bring that down. Now bring down our x minus 3 here in red. X times x is simply x cubed. X times negative 6x is simply negative 6x. How many x? Squared, good job. X times 13 is 13x. Negative 3 times x squared is negative 3. God, that 3 looks terrible again. X squared, negative 3 times negative 6x is negative 18x. And negative 3 times 13 is negative 39. And from here, we will simply combine like terms. We have an x cubed. Is anything else to the third power? No, simply easy bake oven. Set it and forget it. Our negative 6x squared, I'll circle. Anything else with an x squared? Yes, we have negative 3x squared. Negative 6 minus 3 is negative 9. Don't forget your x squared. 13x minus 18x is minus 5x. Then our negative 39, well, we just bring down. Now that completes a review. I don't know if I made an arithmetic error on 11. I'll actually have to go back to it. If I did, do me a favor, just let me know. I just don't feel like going back. So when we are staring down our polynomial, x cubed minus 9x squared, I'm just going to write it in for our answer. Minus 5x minus 39. Man, my threes are just way off today. Don't want to thank Babe Ruth for that one. To what degree is the polynomial? Well, it's to the third. All right. Determine the end behavior. Well, that's a positive 1 in front, so we know that the end behavior is going to go upwards. All right. Back from questions 1 and 2. And how many turning points? Well, it's simply, for the turning points, it's going to be our degree minus 1, which equals 2. And that's how many turning points you will have. And that wraps it up. Let's go.